engineer. After getting his degree from Drexel University, Drexel, he moved to India to work on an open source transition for desktops. He now works at Canonical, where he supports customers with Ubuntu, OpenStack, and many other software projects. Bryan Quigley, thank you.
Thank you. So just as a thank you for the introduction.
Step to the mic, thanks.
Can you hear me?
Yeah.
Yep. All right. So if you're not familiar with open source software or Ubuntu, the basic premise of Ubuntu is it's a Linux distribution, and if you know what a Linux distribution is, it's just a collection of software that makes up an operating system, and it's designed it is designed to be a consistent. Each software package is designed to be consistent in that. So I took a look at what we can look at for interstellar for a manned interstellar expedition, specifically around what you can do, what you need to do with software. No? There we go. So the obvious challenge for software is communication. You've got you're light years away, so if you have an issue and you want help from Earth, that's pretty much not going to happen. A 10-year round trip time for or an 8-year round trip time for Alpha Centauri, and also I haven't seen the numbers shown yesterday was 20 gigabytes per second. The numbers that I've been looking at have been much smaller than that. Obviously, 20 gigabytes per second would be awesome, but that does imply a certain size of communication equipment. And of course, as you get further away, both of these get worse. No. As an aside, when you're leaving Earth, you should take everything you possibly can, because that will be your one opportunity to have no bandwidth costs. That does create other issues with you can't take everything. So you're going to have to prioritize that separately. So I'm going to be talking specifically about software that we're going to want to keep in sync with Earth because it's important for communicating with Earth. Specifically operating systems, data center operation software, and also control systems. Places where you think innovation is going to happen on the Starship or on Earth, where you're going to want to be able to collaborate as much as you can. So specifically with operating systems, let's say you launched an interstellar probe, a manned interstellar mission 30 years ago. They would be running, I think it would be, no, let's just do 20 years ago. They would be running Windows 95 and having the graphics, the video stack that is,
Pardon me. Sure.
and having a video stack that is completely different from what we have today. They won't be able to use as much compression technologies, and so a lot of issues would be mitigated if you can have everyone up to date a little bit more on software. You already have the lag time from the distance. It's better to try to keep each side up to date. And my basic, one of my premises there is the colonists need the source code to everything that they're going to be bringing with them that's going to be in their critical path. So for operations, for anything like that, they need to have the source code because you have no idea when you launch the spacecraft what they're going to need to modify and change. As an example, with firmware, there have been firmware bugs that are date-based. And firmware is basically a little binary on your computer that does a specific task on that machine. There are bugs that are date-based. And so if you launch this probe, this manned expedition, and then, let's say in 2040, there's a date-based bug where it will crash, that's going to happen, and maybe that will be discovered on Earth in 2040 as well. And so there's no way for Earth to have provided the fix for that piece of software. The colonists are going to need to figure that out by themselves. If they don't have the source code for that, they need to reverse engineer that piece of code, which is just an extra challenge. We're sending them into the unknown. Let's not send them with things that we actually know on Earth. So I took the Linux kernel, which is one of the most quickly developed projects currently in existence, and I looked at how we would send this to an interstellar spacecraft. It releases every 3 months, and the total differences, which is just from the last release 3 months ago to this release, is only 8 megabytes compressed. So that's really quite small. If you were to send the full source code every time or every couple years, it would be about 81 megabytes compressed. And if you were to not send source code, you would intend to send an executable, for just one architecture, it would be about 41 megabytes. Just one note for the compressed, the differences between the last release, that includes the commit messages, which is basically context around what has changed in the software. That's really important for what I'm looking at is how are the colonists going to support this software and adapt it. But they need much more than just the source code. So the source code is basically the bare minimum that they're going to need. They're going to need a lot of context around the software that they're going to need, that they're going to want to support. First of all, since we're going with source code, they're going to need how to build it. All a Linux distribution really is a consistent way to build source code. And so they're going to, if we just have them sync a Linux distribution, the packaging for that, they get that. They also need a build system. The one that Ubuntu uses is called Launchpad, and they could use it from any other Linux distribution, but just to pick one. And this will let the colonists take that source code, build it. Another advantage they get is they can build it however they want it, with whatever modifications they make. And we'll get to that in a bit. So next up is how to deploy it. Just because you have the source code for this amazing big data project or other application doesn't mean you actually know how to deploy it in production. And that's pretty essential. So in that way, we need to send them example configuration. That could be Puppet configuration or any other configuration management system. Canonical also has a tool called Juju, which is designed to be they call it an executable white paper. And that basically means you can take this and it encapsulates knowledge about the program, and you just basically can deploy it with knowledge that someone on Earth wrote. And last, in this part, would be how to use it. And that just means documentation for both the users and the administrators and other kind of users in the system. Hopefully that's in the source code, but it might not be. Depends on the project. But that is all the easy part. Next, you need how to debug it. Right now, if you look at the average bug report, it's really a discussion between people who have an issue and the people who are working with the project. And a lot of the discussion goes around, oh, this is how I would debug this part of the source code. And it likely will not be documented anywhere else but in that developer's head. So you want to see what you can get out of bug reports, mailing lists. It could be just chat rooms. Ideally, we would just focus on bug reports because that's the easiest to parse. It also helps provide some context to commit messages in the source code. But this is key. If they don't know the best practices for debugging a piece of software, they're not going to be able to debug it when they have an issue. Next up, if you're going away for 10 years, odds are you're going to modify most of your software that you're going with. So modifying it in a consistent way is really important, and not creating an overlap of work. Many projects don't have good roadmaps. Having better ones for whatever we're going to be using on the Starship would be very helpful for them to not waste time doing something that they're going to get from Earth 6 months later. And lastly is testing. I'm proposing that they're continuously updating their software on the Starship. They need to be able to test this in the same way we test software on Earth, with test suites, continuous integration, quality assurance, to make sure that they can actually run this in all their production systems. If they're going to be gone for 100 years, they need to be able to replace all of their software. And part of the advantage of having Earth send out just the raw stream of data, or maybe with a month buffer for regression testing, is that the colonists, with their own Launchpad instance, which is going to build software and stuff like and build their Interstellar Linux distribution, they get to test they get to choose dynamically on the Starship how often they want to release, how much support they want to give each release. So they can have a faster moving distribution that keeps in lockstep with Earth, and they can have a longer term one for release every 3 years or every 10 years or whatever they want to do for whatever different purposes they're going to have. They also, by sending the source code, they get to choose whatever computing architectures are best for specific purposes. There might be different ones, and I'm going to go into this for high performance computing versus sensors versus mini-sats. Who knows what they'll need to be able to use. The costs for that are going to be time and energy. Energy should be pretty easy, it's just build machines. The total cost of building a Linux distribution in terms of energy is not very high. And colonists might need to have a little bit more debugging skills for those other architectures. So what would I bring today? They're going to need supercomputers. I'm going to just have that as premise, as a assumption. You want the system to work as a whole, but also as independent parts in case systems fail. And the last little blurb is looking at replacement parts, you want to have as few connectors and other things like that as possible. So, the main computer is basically everything you would expect from Star Trek. Your science, navigation, communication, maybe you're just processing. Security will go through here, authentication, everything I mentioned previously about building Interstellar Linux and all of the software that you have. So how I would actually build it today, I would set up pretty much 3 data centers throughout the Starship. You want to have them distributed for redundancy. The technology I would use for that would probably be OpenStack. It's basically your own private cloud, which lets you scale up and down. So you might want to scale, if you don't have a lot of computing right now, you want to probably scale that down. And if you have a lot, you want to use your resources as efficiently as possible. They could have 2 of those data centers running stable and do a cycle. One running testing, and then the next one runs testing for the next 10 years, depending on what cycle of updates they plan to do. The obvious architectures for this from supercomputers on Earth is Intel or PowerPC. I have this reversed. Possibly AMD, depending on what your workload is. So the other goal there is you want to be able to compute things as efficiently as possible on this. That's the core goal. This would also be main storage for data from Earth that you've brought with you and all the data you've received since then, and all science data or anything else you've created on the spacecraft since then. Next up, stationary workstations. For architecture, I would choose what we have in many of our workstations, Intel or AMD. ARM might be there as well, specifically to reduce power usage. The core goal, the goal of these would be obviously to do your average day work, but also I would view this as a second data center. So you want to be able to run the spacecraft just on these and also distribute computing load on them when it makes sense for power efficiency. For sensors and control circuits, you're going to have the Internet of Things on your Starship, but there's no internet, so it's not going to be the Internet of Things, but it will be similar things. Sensors will be very important for keeping track of the environmental controls. If you're growing food, you're going to want to have something tracking each pit of, each farming unit, each living space, and likely sensors, a lot of sensors on the outside of the spacecraft as well. They're going to be running continuously, and you want to have them be very, very power efficient. The obvious ones, computer architectures for that are ARM and MIPS. Sorry, I missed this previously. ARM is what most of you have in your cell phones. MIPS is what most of you have in your routers at home. And one of the architectures for electronically sensitive systems would be PowerPC. There's a few others that have been customized for that, but that could be anything in the future. The obvious operating system for these would be either Ubuntu Snappy, which is a transactionally based, is basically more designed for small sensors and robotics, or FreeRTOS, which is a much smaller than Linux real-time operating system. In looking at it, I couldn't justify mobile or laptops for use by the colonists on the spacecraft themselves, maybe for when they get wherever they're going, but not for on the spacecraft themselves, just because battery tech is not the easiest thing to recycle and creates a whole nother level of things we have to do. It's also not designed very well to last for the kind of time frames we're talking about. And you can't really justify the power losses that might be inherent to them. And also, you're in a giant supercomputer. Why do you want to have a laptop? So in the future, and future things short-term to look at in software, I'm going to be looking at changing. Right now, we look at software changes based on 1,000 lines of code. And that's a really trivial metric, but it's also not useful for our purposes of sending this data far distances. So I'm going to see if I can adapt some pieces of software so that they report in megabytes, compressed megabytes changed instead. I'll also be looking into if we can. Right now, I'll be saying we're going to send the difference file from one release to another. What happens if the spacecraft is down? If their communication is down for that time? Can we reconstruct that difference file and not have Earth have to send it? There's a lot of other redundancy technologies that people have looked at, but I'm going to be specifically looking at for software, because revision control systems give you a little bit more advantage. You're going to get more context later from that software, and so to see how that would work could be very useful. And another one is, I mentioned previously, the colonists need all the source code. If you were to build this today, assuming you don't get Intel or some other major vendor to just back you and say, oh, we're going to just give you all the source code, you can't do that today. There is no fully free and open source friendly hardware that gives you everything you need. At least not that's not about 10 years old now. Elsewhere, things that we're going to change, that could change drastically the strategy here. If we can print new CPU chips, the actual silicon, or whatever we're using in the future, if we can, basically what I mean by that is if we can recycle chips efficiently, we could actually have the Starship change their architecture as they go, depending on their needs. That would obviously impact this. And longer term storage. DVDs are actually pretty easy to recycle, whereas SSDs actually aren't. So that kind of thing and what we'll be able to recycle for parts is something we're going to be looking at as well. So that's all I have. So software is a field that's obviously changing fast, and we have all the problems that are software specific are definitely solvable in the time frames we're talking about. Thank you.